So I just want to look at a couple of other possible sort of system setups or scenarios for remote hydraulic control or pilot control. In some machines, you may find they've got a pilot operated valve like we were looking at that would normally run from a joystick or two single axis pilot control valves sending oil from the cab. But in some cases, a valve of this design will be operated by a electronic joystick. So we may have in the cab electronic controls, and there may be an ECM involved. And then when you get to the hydraulic valve, you find that there's actually pilot lines coming to it. And you think, well, how are they turning electricity into pilot hydraulic oil to operate this valve? And the answer to that, this guy falls into place, is a manifold like this that can have pilot lines running off it, and then have a whole bank of proportional solenoid coils. So unlike our D3 dozer there, where we saw the proportional coils right on the caps on the ends of the directional control valve, there may be hoses running to a pilot operated control valve and a manifold somewhere else on the machine. This could be near the cab or anywhere between the cab and the directional control valve itself. So we've got to get oil here. So there'd be pilot lines connecting, here. These two would connect to either end of a pilot operated spool. So here and here could connect to this valve. And then these two proportional coils are going to proportion the pressure electrohydraulically. So these are just proportional magnets. Receiving electrical signals initially from an electronic joystick, and then possibly an ECM in between, although there are some systems where the joystick has the electronic drivers in it and wires right up to the coils. But usually this is an input to an ECM or a computer, and then the ECM or computer outputs and drives these coils with the right amount of amperage to give us the right amount of pilot pressure to make the spool move and give us the right amount of flow at the work ports. So it's kind of the chain of events. So a manifold, this particular manifold has 8 proportional solenoids on it, and 8 pilot lines can come off it to run 4 functions. So this could be an excavator that has stick, boom, bucket, and swing controls, and those could be electronic joysticks in the cab fed to a manifold like this, and then pilot lines running down to a pilot operated valve. This is also a way to convert a pilot operated machine to electronics if it's going to have grade controls. So if you need to do a retrofit to a machine that's not grade control ready, then that's something like this may be involved. And then in the middle here is an on-off solenoid that would be connected, in the case of a excavator, connected to an activation lever at the entrance of the cab. So when the operator is entering and exiting the cab, they can lock out the hydraulics, or there may just be a lockout switch somewhere on a console in another type of machine. So an on-off valve. And then supplied to this, we've got P and T, so pilot supply from a pilot pump and then back to tank. So we've got pump and tank connections here, and then an on-off solenoid that's going to let the oil then flow. If the activation switch is on, let it flow to all the proportional solenoids, then the proportional solenoids will send oil proportionate to electrical current. It'll make pilot pressures to one or the other ends of the pilot operated control valve spool. So that's just a different method of an engineer laying out a electrohydraulic system. It's still electrohydraulic, but we've got this manifold where electro meets hydraulic. And then, of course, the other way we've already seen the potential for moving spools in a control valve, mechanical spools, electrically, is to have direct electric spool actuators. So we saw this as an option on our Bobcat skid steer, where we can have just a bidirectional motor in here driving a belt and a worm gear, and then a position sensor built into the actuator itself. And this can be a way for a manufacturer to offer, machine manufacturer to offer electronic controls of an existing mechanically operated valve. This is the least common, though, even though we saw this on the Bobcat skid steer. This is the least common way of electrifying controls that I've seen in the industry. So generally when we get electronic inputs, electronic joysticks, even though they're capable of having a computer output to this type of actuator, usually there's pilot involved in between, and we're using a pilot operated DCV, and either the solenoids are in a manifold like we just saw, or on the valve like we saw on the D3K. Going forward in the industry, it seems like this is probably going to be the most common setup you're going to see, where the solenoids are located right at the directional control valve rather than having a manifold somewhere. But again, this valve is not direct electric movement of the DCV spools. There is a pilot pressure being fed, or actually being created by a pressure reducing valve in this DCV itself, and that's providing the pressure to the solenoid valves, which are going to proportion that oil pressure then into the ends of the spools for movement. I'm not sure who the supplier is to Caterpillar of this particular valve, but it's a fairly popular model. I've seen this sort of style in a lot of excavators, articulated trucks, and now in this dozer. And then of course we've talked about this valve, our auxiliary valve. If auxiliaries are optioned onto a grader, a Volvo grader, they're using this Husco valve. That again has got the solenoids mounted right at the directional control valve. This particular one's a little bit different the way they do it. We've got 6 solenoids, but you notice there's sort of 2 styles here. We've got 3 on-off solenoids and then 3 proportional solenoids. Instead of having 6 proportional solenoids, they've got one that sort of flips where the oil is going to be sent, whether it's sent to this end of the valve or this end of the valve. So that's just done by an on-off solenoid. And then the proportional solenoid decides what the pilot pressure is going to be pushing the spool from either side. So there's actually a drilling that goes from this manifold right down through the valve body to the cap on the other end. So all the pilot pressure is controlled and manipulated from the one end of the directional control valve. So this guy is Husco. I'm not sure that one in the D3 isn't also a Husco valve, but this one's a little more blatant about advertising their brand on it. If you ask Caterpillar, they will say this is a Caterpillar valve because it's built to their specs, which is often true. They may make particular demands of a supplier, but this may be a Caterpillar valve too. They do make some directional control valves. This looks a little more off the shelf though than typical Caterpillar valve.